Welcome to this video on the topic of Year 8 Mathematics, Algebraic Factorisation. In this lesson, you'll learn how to reverse the expansion of brackets, also called factorising. Factorisation is the reverse of algebraic expansion. Algebraic expansion may be reversed by firstly identifying the greatest common numerical factor, then identifying any common variables, after which writing these outside the brackets, and finally dividing each term by the common factor. Consider 8x plus 12. If we wanted to reverse the expansion on this expression over here, we can factorise. Factorise being turning this into something with brackets as shown over here. We have a product, and then inside the bracket we have an expression. If we expand this expression out, we get the expanded form on the left. If we factorise the expanded form on the left, we get the factorised form on the right. So what we're learning is how to go from the left over here and turn it back into the right over here. Let's start off example 1. Reverse the algebraic expansion on the following. In other words, factorise. First one we have 8x plus 12. What we want to do is we want to rewrite this expression using brackets in its most simplified bracketed form. First thing we need to do here is we need to look at what's common between 8 and 12. So I'm going to write 8 and then I'm going to write 12 over here. Next, I'm going to break 8 and 12 into its prime factors. This can be done by either just knowing what the prime factors are, knowing how to do factor trees, or just using an aid like a prime factor chart. For 8, the factors are 2 times 2 times 2, and for 12 it's 2 times 2 times 3. So for 8, I'm going to write it out as 2 times 2 times 2, and for 12 it's 2 times 2 times 3. Next, I'm going to look at what's common. I know that the 2's are common, and I know that the 2's here are common. So I'm going to have a common factor of 4. Thus, outside the bracket, I'm going to have a product of 4, and then inside, I'm going to have my expression. Now the question is, what do I put inside? Well, whatever we didn't find that was common between the 8 and the 12 is going to go inside in its place, so we're going to have a 2 and a 3. And then finally, remember, we have variables. It wasn't 8, it was 8x. So instead of 2, we're going to get 2x. And therefore, we find our most factorised form for 8x plus 12. Alright, once more. 15a plus 20. We start off by gathering the coefficients and looking for the prime factor breakdown. Again, I'm just going to use a prime factor chart. For 15, it's 3 and 5. For 20, it's 2, 2 and 5. The common factors across both of these numbers are 5, and that's it. Thus, the product outside the bracket is going to be a 5. Inside the bracket, it's going to be 3, and I need to put the variable on there, so it's a. Plus, then I have 2 and 2, so this is going to be 2 times 2, which is 4. And thus I've found the most factorised form of 15a plus 20. Remember, 15a plus 20 is the same as 5 in brackets 3a plus 4, because if I expand this, I should get that. Alright, let's look at some trickier examples. Next, we want to factorise 3x plus 9xy. To do this, I start off by gathering the coefficients 3 and 9. I know that 3 is a prime, so that's its factorised form there. 9 on the other hand is a composite number and it's made of 3 and 3. Looking at what's common, I have a 3 and I have a 3. So the common factor here is 3. Now, in the previous example there was only a singular variable. However, in this example over here, we have x split across both the 3x and the 9xy. Because that's split across both of them, we're going to put that down as well as the product, or the common factor in the product. Next, opening the brackets, we have to decide what goes inside. the x is over here, and the 3 only had a simple factor of 3. So then we don't have anything left. So in place of that, we're going to put a 1 as a placeholder. Next I put down the plus. After which, I turn my attention to the 9. The remainder of here was just a 3. And we didn't do anything with the y, so the y is just going to go there. So the factorized form is 3x in brackets 1 plus 3y. Alright, moving along. 4a minus 20ay. I have a 4 and I have a 20. The 4 can be factorized into 2 times 2, and the 20 can be factorized into 2 times 2 times 5. Therefore, my common product is 2 and 2 as shown. Therefore, we're going to get a product of 4. Looking across both of the terms, we have a common variable of a. Open the bracket. The 4 has had all of its factors used up, the 2, and the a, so we're going to do a placeholder of 1 again. Instead of a plus, we're going to go minus because we have a minus here. So the minus transfers down. And then finally, we have a leftover 5 and the leftover y. Therefore, the factorization of 4a minus 20ay is 4a in brackets 1 minus 5y. Okay, next degree of complexity, it ramps up a little. And we ask ourselves the question, gathering the coefficients, what is common across both of them? For 20 and 36, we look up their prime factors. 2, 2 and 5. And for 36, it's 2, 2, 3 and 3. We can see that the 2 times 2 is common across both of these. So we're going to get a common product of 4. Next, we have to look at the variables. We have x squared y and xy. We can see that their x's are common across both of them. So we take a singular x out to match the lowest count, so x over here. On the y's, on the other hand, we have 1 y each, so we can take that from both. Open the bracket. For 20, we have a leftover 5, and we have a leftover x. For the 36 xy, we have a leftover 3 by 3, so that's 9, and both the x and y were used up in the product. So therefore, our simplified, or our factorized form is 4xy in brackets 5x plus 9. Okay, next one. We have negative 18 a cubed b minus 30 a squared b. Starting out, we gather our coefficients 18 and 30. We look for the prime factors. 18 is 2, 3 and 3. 30, on the other hand, is 2, 3 and 5. Common factor across these two is 2 times 3. So our product outside is going to be 2 3's, which is 6. Next, we look at the variables. We have an a cubed b and an a squared b. The common a's across here are a squared, and the common b's are just b. So we're going to go 6 a squared b. Finally, notice that we have a negative on both of the coefficients here. Because we have a negative on both the coefficients, we can just take it once and move it outside. So therefore, inside the bracket, we're no longer going to have negatives on this guy or this guy. Now, what remains is we have a remainder of 3 and a singular a, plus we have a remainder of 5. And therefore, we find that the factorized form is minus 6 a squared b in brackets 3a plus 5. Moving down, we have extension, factorizing with double brackets. Now these ones are a little bit tricky. For these ones, while there are methods to be able to reliably factorize these methods are a bit out of reach for Year 8 students. So instead, we're going to have to rely on the guess and check method. Now, with the guess and check method, we know that these guys are going to be transferred into two brackets. The question is, what goes inside the brackets? First things first, we know that we're going to get an E and an E. Why? Because we're multiplying two E's together here, there's an E squared. Next, at the end, we know that we're going to be dealing with something that turns into 10. Now, something that turns into 10 could be 5, and it could be 2. So if we have a look at what we've got here, we know that this is going to expand out to E, E, plus E5, plus 2E, plus 2, 5. Expanding this, we get E squared, we get 5E, we get 2E, we get 10, where these guys over here turn into 7E. So we know that this is correct. Hence, we know that our factorization is E plus 2, then in brackets E plus 5. Alright, moving along. C squared plus 8C plus 12. Again, we want to factorize these. We see that we have a C squared and we have a 12. That implies that we're going to have a C at the front here and we're going to have a C over here. On the other hand, we have the 12. We ask ourselves, what are the factors of 12? Well, they could be 3 and 4. Checking that this is correct, we know that we're going to get CC plus C4 plus 3C plus 3, 4. Expanding this, we get C squared, 4C, 3C, 12. When we combine these, we end up getting 7C, and we know that that doesn't match here. So what we discover is that this can't be correct. We have to pick two different numbers. We have to pick two numbers that are going to multiply out to give us that 12 at the end over here. Trying again, we know that 3 by 4 is 12, but we can also do 2 by 6. Expanding this out, and lo and behold, we get the correct expansion. Therefore, we know that this can be one of the factorized forms for this shown over here. Now remember, there are faster ways to be able to factorize these sort of expressions here. However, the trouble is, some of the methods are a bit out of reach for year 8, so for now, you're going to have to focus on the guess and check, and maybe you'll find the fast method on your own.